John said, I'm going to be talking about ROS, specifically about how that interfaces with TurtleBot, AWS RoboMaker, which was announced in November, and then the DeepRacer. So a little bit about myself. My name is JD Fiscus. I'm a software engineering manager at Accenture. I have a background in full stack development. Graduated from the Udacity Robotics Engineering Nano degree last July. And then in 2017, I went to MIT Internet of Things Bootcamp. Currently, I'm working through AWS certifications and going through Pi Image Search Guru, which is a computer vision course. That's a long way of saying I'm a huge nerd and I'm proud of it. So if you have any questions or want to geek out on something afterwards, I'll be around to help you out. So I wanted to talk about what a TurtleBot is. I have an example that we built as a team at Accenture and some things that we did differently. So there's 3 different versions. The one you're looking at on the screen is called a Burger. The other ones are called Waffle, which has an Intel camera on it, and then a Waffle Pi, which has a Raspberry Pi camera on it. So the biggest thing to note about the TurtleBot is it comes with a LiDAR so that you can do SLAM, which is standard localization and mapping, and navigation. We'll kind of talk about that in a little bit more detail and talk about some autonomous features that it can also do. So one of the really cool things about it is since it's all open source, you can actually go and look at the 3D model of each individual TurtleBot and also some like open source projects that they did of different models. So you can actually download those 3D models and print out through an STL file and 3D printing what they call a waffle plate. So we were able to add on to our TurtleBot because of this functionality of using their open source. Some other things to note is that it uses a Raspberry Pi. They have OpenCR, which is basically the driver, and then I'm going to butcher this name, but Dynamic Soul motors. So this is our build of the TurtleBot, which I also have up here. We call her Annie, or Autonomous Annie. Kevin, I have a little bit of a video of him demoing it. I didn't want to bring it here and actually try and demo it here. It's a little hard. But some of the things that we did that were different was when we started working on this TurtleBot, RoboMaker didn't exist. So there was no functionality that was directly connected to AWS. And we knew that we wanted to connect through AWS Web Services and interface with the robot through different physical devices. And the way we did that is through the MQTT protocol in AWS IoT to then send commands directly to ROS. So the example we used is we basically have a joystick that you can run through like a web server and just a regular browser, and then we also wanted to communicate through Alexa. So we did with Alexa 2 ways. We had just a regular Alexa that you could access anywhere in the world and send commands to the TurtleBot. But then we also installed Alexa on the Raspberry Pi and put a microphone and speaker connected to Annie so that you could directly communicate with the robot as well.
Hi, welcome to our demonstration of our TurtleBot, Autonomous Annie. Today we're going to show you how we control the TurtleBot in 2 separate ways, using voice control through Alexa, as well as a visual interface that we made with Vue.js. So the first thing, the voice control. Alexa, open TurtleBot.
Greetings from Autonomous Annie. You can say things like, start Autonomous Annie.
Annie, start.
Autonomous Annie, start.
Annie, stop.
Autonomous Annie, stop.
Alexa, cancel.
Goodbye.
So as you can see, we can start the TurtleBot as well as stop the TurtleBot using voice control. And we can also transition over to our UI and control using this joystick the movement of our TurtleBot. We can stop, go backwards, stop, go forward, pause. Thanks for watching our video on Autonomous Annie.
So some other things that TurtleBot can do is it can do SLAM. And this is an example from their documentation or Robotics' documentation. And it is a visual representation of what the robot sees, essentially. So the blue and pink outline is basically the robot's driven around the ring and created a map of its environment. On the far, like my right, is what the camera's actually seeing, and it's taking those images and the images that it's already built as it went around the map, and it's trying to determine where it's at in its location. Right? And so the piece where you have like all these green arrows, those are basically particles that are determining in the center of where the robot is based on its environment. The green arrow is the navigation goal. So just like we could say, Autonomous Annie move forward, we could actually say, Autonomous Annie, go to JD's desk. If we had this mapped out and a navigation point on this map, it could actually navigate throughout the room on its own to a particular navigation point. TurtleBot also has something called auto race, where you can actually look at the competitor's code of how they did autonomous driving with the TurtleBot as a competition. They have their own track. The track's open source. You can look through that. The other things that they added to it were stop signs, street lights, buildings, and collision detection, so that you could actually navigate through this track with the TurtleBot. Everything on the TurtleBot is written in ROS, right? So everything that's on the Raspberry Pi is communicating with another server that's running ROS core, and that ROS core is basically allowing you to communicate between the robots and the main server. So the cool thing about ROS is it's an open source framework. It's really cool to hear that Forden is using it in cars. That's really awesome. I didn't know that. It allows you to not have to reinvent the wheel. Right? So you don't have to build a custom API to interface with your robot or define a specific MQTT topic. All of that is configured inside of ROS. The languages that you can use are C++ and Python. It's really built around this idea of publish and subscribe, and I'll get into that a little bit more, but if you're familiar with software engineering, at least for the web, it's also called like the observable pattern. It has a ton of plugins and tools that are open source and you can work with. We'll go through some of those, and then it's extendable. So if you wanted to write your own service or class or package, essentially, you could do that in either Python or C++. One of the main components of ROS is this idea of nodes. A node is really simple. It's any executable file inside a package, and it can communicate with other nodes. So the example we have here is run package name, and then the node. So for instance, if I wanted to spin up the TurtleBot, I would say ROS run TurtleBot, and then whatever node that I wanted to start the robot. In this case, the example would be TurtleBot underscore bring up. And that's going to create all the nodes that you need in order to interface with the robot itself, or getting the much of that that you would want. There's this idea of topics. Topics are basically how you're communicating between two nodes. So it's the bus exchange. They have a very particular message type, which is basically like defining what your object is going to look like of the message that you're going to send. And then the example is you can actually list all the topics, which is really helpful when you're trying to debug and you want to know what's actually going on. And then you can subscribe to them, echo. And what that's going to do is actually print out everything all the data that's coming back from this topic. So if you look at the blue circle, that's one node. The red is actually the topic. It looks like a URL or a file path. You don't have to follow that convention. It's just the easiest and most clear that I've come across. The other thing that you'll notice is it has Turtle1, right? So you can have a fleet of TurtleBots and communicate specifically through a topic by just changing that particular variable. So it could be TurtleBot 2, 3, 4, 5, whatever. Or you could have it communicate to all TurtleBots that are listening on this topic and just have like turtles or something. So this is where we're going to talk more about publish and subscribe. I call it pub sub. Some people call it the observable patterns. The idea is that you're going to have one node that's going to be publishing information to a topic, and then you're going to have another node that's going to be subscribing to that topic. So when you're distributing data to the topic, you're doing a single push, and it's a fire and forget. And what that means is you're just sending it out, and anyone that's listening to it will get that data. You're not going to wait for a response back. With a subscribe, you can have multiple subscribers of nodes to a single topic. A really good example of this is something probably all of us see every day, and that's push notifications on your phone. So the idea being that you have one entity, a company or a sports team or whatever, that's going to send out information, whether it's news or a sale or whatever. That single entity will publish to a single topic and distribute that information to 10, 50, 100, a million different people. They're all subscribing to that single topic. The same idea applies here with ROS, but you're communicating through different nodes in the package. There's this idea of services. So a service is a request and response. So it's similar to a topic in the same way it's kind of set up, but it's different in the fact that it's almost like an HTTP request. So you're going to fire off information, and then you're going to wait for it to respond back. Some examples of that are the map server. So we saw when we're doing the navigation, it kind of comes out with, or you can actually print out the map of what you've already mapped out. You would send that information to the map server, it would generate the file, and then return that information back to you. You'd also write custom services, for instance, like doing a calculation. I want to send 2 plus 2 and get the response back from that. So I send my request, and I wait for the response, and then have my information. Actions, I just started learning about, so it's a little new for me. The idea is that you have goals, which is basically the intent for the robot. You can think of it as like, okay, my goal is to navigate to JD's desk. And that's the action's goal. You also have feedback, which is constantly sending information back about the progress, for instance. So it's incremental information that's coming back to you. And then the result is very similar to feedback, except because you're getting information back, but it's only sent back once. So it might be like the final destination of where the robot is. And then this is a graph kind of showing how that information goes from the client application to the server application and back and forth, but over the ROS kind of topics and protocols. So this is kind of like a diagram flow of how this actually works. So you can see on the top, you have a node communicating to a service. It's going to get a response back and go back to that node, even though it looks like it's just going forward. And then you also have multiple different nodes that are all publishing a single object to a topic. And then everyone that's listening to that subscription of that topic will get each one of those published, or the published message that's being distributed. This is kind of a list of the tools and plugins that you get with ROS. There's this thing called RQT, which basically has a bunch of different plugins. You can look at your topics and understand like what metric data is maybe coming back from your battery or your velocity. How do you increase that? Make sure, or you could actually take the graph information. Yep.
Can I just ask you what is
Sure. Yeah.
So, I understand. So, one is publishing one, and can you just?
Sure. Okay. So the question is, when we're talking about topics and like what is publishing and who's receiving it.
Yeah.
So, if, for instance, so in the demo, when we said Alexa, tell Amy to move forward, what's happening is we're sending information from Alexa through MQT to ROS. That ROS node is taking that information and publishing it out. So it'll publish over a topic that might be velocity, right? So we want to tell it to move forward at a speed of 2%, for instance. And so it'll move forward X amount, probably in meters, at a certain speed. So the node that actually turns the wheels